Good morning, everyone. Our next topic under iterative numerical solutions is the incremental search method. So under this topic, we only have 4 steps. The first step for incremental search method is to determine values for the function of x for successive values of x in some interval to be searched until a sign change occurs in the function of x. Again, this is an iterative way of solving for the root of the equation, wherein the succeeding values of x in solving for the next value in the table will be dependent on the sign of our first function of x here. If there is a sign change from positive to negative or from negative to positive, it indicates that there is a root value between these assigned values. So for example, in the first substitution of the value of x, the answer is positive, and in the second substitution of the value of x, there will be a change from positive to negative. That means there is a root between these values, or it may also mean there could also be a discontinuity in the function. The closer approximation of the root is the value preceding the sign change. So beginning this value again, we determine for the value of x for the succeeding values of x using the next smaller increment than previously used until the sign of f of x changes again. So our increments may be in ones, it may be lowered to 0.1, and if again there will be a change in sign, it could be again lowered to 0.01, and so on until you achieve your desired error. So the procedure is repeated with progressively smaller increments of x until the desired error is achieved. And the last step is to compute for the error e, which is equal to the absolute value of the function of x. To completely illustrate our incremental search method, let us take this example. We are asked to find the root of the given equation or the given function. F of x equals x cubed minus 10 ln of 2x, and we are given xi, which is 0.3, and e, which is equal to 0.001. So we need to stop after achieving the value of e, which is 0.001. So if you have noticed here, we have here our table. This is the table used in ISM. So the first column indicates the iteration number. The second column indicates the change in x, or the delta x. We have here the third column is for xi. The fourth column is for the function of x, the value of the function of x after substituting xi, and e here will be our error. So the last comment is just intended for the comments so that you could understand the incremental search method. So we have here for iteration 0, or for our initial iteration, we have here the delta of x, which is equal to 0, since we have not yet changed any value of x. So the delta x for initial condition will always be 0. From the given, the value of our xi is 0.3, so that's why we have here 0.3. How do we get the value of f of x? So we will be substituting the value of xi to our function of x. Our function of x is x cubed minus 10 ln of 2x. So if we will substitute value of x which is equal to 0.3, our function of x will be equal to, let me move so it could give me more space to solve. Function of x will be equal to, so we have 0.3 quantity cube minus 10 ln of 2 times 0.3. So solving in our calculator, that will give us 5.135256, or in our module that value may be longer, but for illustration purposes we just rounded it off to at least 6 decimal places. So the value of x here is what is reflected in this column. And of course, our error is just equal to the absolute value of the function of x. So that will be equal to 5.135256. So again, take note that the initial sign of our answer in our f of x is this is positive. Take a look. The initial sign is this is positive. So let's move on to iteration 1. So this is for iteration 0. Let's now move on to iteration 1. So for iteration 1, we have here our delta x is now changed to 0.3. So our xi here, our delta x here will be equal to 0.3. So that will be our change in x from 0 to 0.3. But what is the value of xi? Xi will be equal to your delta x plus your initial xi. So that means we will be adding 0.3 plus here the 0.3. That makes it 0.6. Is equal to 0.3 plus 0.3. That gives you 0.6. So that's why 0.6 is reflected here. And then we will substitute that value 0.6 to the f of x. So let us now solve for f of x. That will be equal to 0.6 cube minus 10 ln of 2 times 0.6. So that will give you negative 1.607216. Now, take note that the sign of f of x in iteration 1 is negative. So in our previous slides, it was mentioned there that if there is a change in sign from positive to negative or from negative to positive, there may be a root in between these values. So we need to decrease the change in x or the delta x if there is a change in sign. So it was mentioned here in the comment, there is a change in sign from positive to negative here. So if there is a change in sign, we need to lower the increment of delta x. So we need to lower down the increment of delta x. So let's now go to iteration number 2. So since there is a change in sign, again, let us just neglect or the iteration 1 because there is a change in sign from positive to negative. In iteration number 2, so what is the value of delta x? So we have here iteration number 2, iteration 2. So since there is a change from positive to negative, we are asked to lower the increment of delta x. So again, let's just neglect this one because there is a change from positive to negative. And we will lower the increment here from 0.3. We will lower that to 0.1. So our delta x now will become 0.1. This is lowered from 0.3 in iteration number 1. So what will be my value of xi? So the value of xi again will be equal to your delta x plus your initial value of xi. So that means 0.1 plus 0.3. Why 0.3? So again, we said that we have neglected the iteration number 1 because there is a change from positive. So we will be referring to the previous xi, which is 0.3. So 0.1 plus 0.3 because again we have neglected the previous iteration which has changed value from positive to negative. So that's why our xi now is 0.4 and we will substitute that value that is equal to 0.4 quantity cube minus 10 times ln of 2 times 0.4. So it will give us how much? 2.2954336. And of course, the error is just absolute value of function of x, so that is equal to 2.2954336. So take note that the sign here is positive. So the initial value is positive, therefore we need to maintain that the value of the function here is positive. If the value of the initial f of x is negative, so you have to maintain it to be negative. So okay, the answer here is positive, the initial is positive, so there will be no change. So we will, since there is no change, we will continue with the iteration using the same value of xi. Basta wala nag-change ang sign, we will continue to use the value of delta x as a sign. So we have here, let's now go to iteration 3. In our iteration 3, our delta x, our delta x will still be 0.1. Why again? Because there is no change in sign, there is no need to lower the delta x. So our new xi here will be equal to 0.1 plus, what is the previous? That is 0.1 plus 0.4. So 0.4. That gives you 0.5. Then we will substitute 0.5 to the function. Function of x is equal to 0.5 quantity cube minus 10 ln of 2 times 0.5. So that will give us 0.125. And again, the sign here, take note, is positive. And solving for the error e is just equal to the absolute value of the function of x. That will give you 0.125, which is also positive. So this one is the value here, and this one is the value here. So let's continue with iteration number 4. So iteration number 4, so we have here iteration 4. We have here the delta x that is still equal to 0.1, and what will be my xi? 0.1 plus 0.5. That will give me 0.6. Substituting the value of 0.6, our f of x will be equal to 0.6 cube minus 10 ln of 2 times 0.6. Again, in this value, in substituting the value, the answer is negative 1.607 to 15568. Again, you will notice that there is a change in sign. From positive, it again becomes negative, by which it indicates that there is again a value or the root between our xi value and the next iteration. So since there is a change from positive to negative, we need to lower the delta x. So we need to lower the delta x. Again, if we are asked to solve for the error, would just be absolute value of a function of x that will give you 1.60721556. So in iteration number 5, iteration 5. So in iteration number 5, again, since this one has a negative value, so again, we'll assume or we will neglect iteration 4. For iteration 5, we will lower the delta x from 0.1 to 0.01. So we will lower it again by a hundredths. So 0.1, 0.01, 0.001, and so on. So our new xi, this is again, just to take note, lowered from, how much is the initial value? 0.1, so because there is now a change in x. So the value of xi will be your delta x plus your previous xi. That will be 0.01 plus. So since we have neglected the fourth iteration, that will be 0.1 plus, again, 0.125. So plus 0.125. So that will give us 0.126. So solving for the function of x, that will give us 0.126. Oh, what is the value? Sorry. Our value for xi is not 0.125, but rather I have pointed at f of x. So that will give us supposed to be 0.1 plus our value of previous xi. So that will be plus 0.5. So that will give us 0.5. That will give us here, the answer is 0.51. So here we substitute 0.51 cube minus 10 ln of 2 times 0.51. So that will give us again negative 0.065375,273. So again, if you will notice, there is again negative. So again, since we are to maintain only positive because the initial value in iteration 1 is positive and the answer here is negative. So again, we need to cross that out or neglect again the iteration 5. Let's now go to iteration 6. So since there is a change or still it is negative, we need to again lower the value of our delta x. From 0.1, we will make that into 0.001. And then our xi will be 0.001 plus the previous. Still, we are 0.001 still to the previous positive value of xi, that is 0.5. So that will give us 0.501. So your function of x will be equal to 0.501 cube minus 10 times ln of 2 times 0.501. So that will give you 0.105771474. And of course, the value of error for iteration 6 is equal to absolute value of f of x is equal to 0.105771474. So now the answer is positive. So you have to continue to solve for the root, maintaining here the values which is positive. So if you have noticed that in iteration number 7 to iteration number 11, there is no change in sign. So the values of f of x here are all positive. So here, these are all positive. Since there is a change in sign in iteration number 12, notice that here, since there is a sign change in iteration 12, notice here that again the delta x is lowered into 0.001. And again, it reveals or it gives us an answer of positive. We stopped at this value because we have already attained the error, which is 0.001. So the error achieved should be less than or equal to 0.001. Iteration number 16 has not yet achieved because this is 1 and this is 2. So you still continue until the value of your E achieved is lower than the required error. So what is the root of the equation using the ISM? So the root of the equation will be the last value of xi. So what is the last value of xi here? So the last value of our xi is 0.5063. That's why the root of the equation given is 0.5065. So that's all for our incremental search method. See you in next topic, which is the half interval method.